Linux and files, and files, and files. When you ask anybody what's a file, you practically always get an answer that is more or less correct, and also always more or less the same. It will be something like, a file is some data on disk, like a PDF, or an MP3, or a PowerPoint presentation. And every so often you get the answer that it can be a configuration file, or a program that you can start. Now these answers are not incorrect, but they're also not complete. Maybe you are familiar with the very bold statement that says that everything in Linux is a file. Okay, everything is a file. That must be incorrect, surely. I mean, a disk is not a file, is it? And a process in memory, surely that's not a file. And what about kernel parameters? These are not files. A command line pipe, a printer. Well, sorry, but they're all files. So everything in Linux is a file. Before we go into that, we have to tackle something else. When I tell you that etc hosts is not a file, would you believe me? When I tell you that dev.tty is not a file, would you believe me? Probably not. etc hosts and dev.tty are not really files, but they're names in directories that refer to a file. And this file is a number, and we call it an inode. So the name of a file refers to an inode which holds all the properties of the file, including pointers to data blocks that contain the actual data of the file. All Linux file system types work with inodes. The inode is a unique number that is referenced by a name or by multiple names. So a single inode, or a single file so to say, can have multiple names. The size of an inode varies between 128 bytes and 1 kilobyte, depending on the type of file system. The thing is that the inode contains metadata, like the type of file, the size of the file, timestamps, an owner, a group, and some other stuff like actual pointers to the file's data blocks. Now let's have a look at one. Now to create an empty file, I can use the touch command. So I want to see the inode of a file. I can run ls-li, and what we see is the inode number and its content. Like the first character, the dash, says that it's a regular file. Then we see 9 bytes that have to do with permissions. The dot refers to SE Linux, which I am really not going to discuss here because then this video would definitely run out of time. The one that follows is interesting because this one simply means that there's only one file name that refers to this inode. So there can be more? Yes. I will demonstrate that in a second. Next field is the owner. Then the group, the size, the date the file was last modified, and as I said, the name is not part of the file, so the name is not in the inode. Now to prove this, we're going to create some additional names which all reference the same inode. So we use the ln command, which obviously stands for link. And now we see that there's 2 file names that point to the exact same inode, and also we see that the link count field is up by 1, and we can add a third name. And we see that the inode is identical and the link count now is 3. Now to finish this little experiment, let's put some data in the file. And we list the files again. And we see that they all have 6 bytes. Yes, of course, because it's the same file. And if we empty one of them, we see that they're all empty, because it's the same file. And it really doesn't matter if you remove any of these file names. It will simply decrease the link count until it's absolutely 0, and then the file will be gone. The inode is freed and it can be used for another file. Okay, now we know that a file is more than just a name. Now let's have another look at this very first field of the output. So we create one more file, and we said that the first field meant that it was a regular file. So in fact this is the file type. But what about a directory? So if we create a directory and run the ls again, we see that mydir starts with a D. And if we would list the contents of the dev directory, which stands for devices, we should find other file types. So what we see is some files have a C and other files have a B. This is not a sysadmin training in any shape or form, but let's just say that a C stands for character device and B stands for block device. Now these are different device types. So if I run ls-l for /dev VDA, it says that this is a block device. And tty, it says it's a character device. Another very cool command is the file command, which helps you to find out what type of file it is. Now VDA is a block special, which in this case means disk. And tty is a character special, which in this case means terminal. And Rocky is a directory. Now trust me, the file types we discussed are not the only ones, but I hope I was able to convince you that a file is not just an MP3 or a PDF. And if you want to have a quick overview of all file types, please check out the description of this video. Now to finish this, I have a question. Please run the following command and try and explain the output. And you can check the description for that as well. And we're done.